This is the first video covering Chapter 9 of Pre-Calculus 11, and this video specifically is the first of two that's going to focus on linear inequalities. So Chapter 9 is all about different kinds of inequalities. So you'll see linear ones, you'll see quadratic ones, you'll see ones with one variable or two variables. So let's just go straight into it. If you're wondering what inequalities mean, it is something that you should have seen before. Probably back in grade 9, you would have seen something that looked maybe like x plus 3 is greater than or equal to 7, right? And so this is something that you would have had to have worked with. You probably would have graphed it and maybe made something on a number line that looked like this, right? That was always dealing with inequalities that had one variable in them. It would have just been x or maybe some other letter. This year, for Pre-Calc 11, we're going to be dealing with inequalities that have two variables. And so that's kind of the main question of this video is how do we deal with an inequality that has two variables? For example, let's say we had something like y is greater than or equal to 2x plus 1. Now that should, at first glance, look pretty similar because it does just look kind of like a linear equation. And we are going to see a lot of similarities between them, to the point that we are actually going to spend most of our time with these things graphing them. It's just that the graphing is going to be a little bit more complicated than the simple graphing of linear equations that you did a lot of in grade 10. So when we graph these things, we're going to be looking to show all of the possible points that fit our inequality. So, to do that, step one, the first thing we're going to do is we're actually going to completely ignore the inequality. We're going to pretend it's an equation, and we're going to graph it like an equation. Because that's something we know how to do. So we're just going to graph y equals 2x plus 1 instead of y is greater than or equal to 2x plus 1. So you are going to need graph paper if you're taking notes along with this lesson because it is just going to be mostly a lot of graphing. Quick refresher on how to graph linear equations. So y equals 2x plus 1. So remember, this is slope-intercept form, which is y equals mx plus b. So 2, this is our slope, and 1, this is our y-intercept. And just a reminder, slope is rise over run. Which is your vertical change and your horizontal change. So let's get ourselves a graph sketched out here. So we're going to draw ourselves a 5x5 grid. And then we're going to try graphing this thing. All right, so for y equals 2x plus 1. We're going to start, just a refresher on graphing these things, by plotting your y-intercept. So in this case, our y-intercept is at 1, so we're going to draw ourselves a point at 1. And then once you've got your y-intercept, you're going to use your slope to get more points. So in this case, our slope is 2 over 1. So from that point at our y-intercept, we're going to go up 2 and right 1 to get a point there, and do it again there. Or we can go down 2 and left 1 to get points there, there, and there. And so now we can just draw our line through those points. When you're drawing inequalities, which is what we're going to be doing soon, it is really important that you make sure your line goes all the way to the ends of your grid for reasons that will make sense pretty soon. So just make sure that you don't draw a line that just looks like this. Go as far in each direction as you can. All right, so we've graphed the equation, but now we want the inequality. So to graph the inequality, we need to figure out where it's true. So we don't want to just be equal to 2x plus 1. We want y values that are greater than or equal to 2x plus 1. And that's going to be a lot more points. So the key thing to remember before we start this is that line that we just got. The line represents all the points where y equals 2x plus 1 is true. Right, so for example, if we put 1 in for x here, 2 times 1 plus 1 is 3. And so when x is 1, y is 3, right? That's where this point right here comes from. But any point with a bigger y value would also fit that inequality for that particular point, right? So if you had y equals 4, and we were going with 4 is greater than or equal to 2x plus 1, well, that's definitely true, when x is 1. Or 5. 5 is also greater than or equal to 2 times 1 plus 1. So there's lots more y values that are going to make this true than there were when we were just doing a simple line. So what we want to find out then, our goal for graphing this thing, is where is y greater than 2x plus 1? Because we already got the equals part down. That part's easy. And all that is, for any question like this, the part of the graph that you want is always just going to be the area either above or below, or you can think of it to the left and the right of your line. That's it. So your inequality is represented by the space or the area on one side of the line. It's up to you to figure out which part of that area is the one that you actually want. And that's going to be a pretty straightforward thing to figure out. It's just going to be a little bit of calculating. So to find out, all we have to do is pick one point, which we're going to call a test point, from each side or each part of the plane. And we're just going to plug them into the inequality and test them. So going back up to our graph, we're going to pick one point sort of from this green area, one point from this yellow area, and we're going to decide which one of those is actually what we want. It's often going to be easy to pick points that are along your y-axis for reasons that I'll get to in a sec. So I'm going to pick a point at 0, 0, right? That's 1 point below the line, and then 0, 2, 1 point above the line. It's definitely going to be easiest for you typically if you pick points that have the same x value, because it's going to cut down on the work we need to do. All right, so coming back down here. So we're going to test 2 points, 0, 0, and 0, 2. So we have our inequality, y is greater than or equal to 2x plus 1. I'm going to plug 0, 0 in for x and for y. Well, 2 times 0 is just 0. And 0 plus 1 is 1. And so we end up with 0 is bigger than 1. And that's not true, right? That's false. Which is fine, inherently, because we know it should just be one of these regions. So as long as the other one ends up working, this is totally okay. So we're going to go through the exact same steps, but now we're going to be plugging in 2 and 0. And you can see here both reasons why it's good to A, pick values that are on the y-axis. So when x is 0, it tends to just cancel things out and it makes life easier. And also, picking values that have the same x value means we don't have to do these calculations twice. So 2 times 0 plus 1, we just did that. So we already know that that's just going to give us 1. And so we end up with 2 is greater than or equal to 1. And this is true, right? 2 is bigger than 1. And that's how this should always work out. 1 point should give you a false statement, and 1 should give you a true statement. If you didn't get 1 true and 1 false, you've either messed up on your calculation somewhere, you've picked your points wrong, or you've drawn your line wrong. It's going to be up to you to figure out which one is which. So there we go. 1 false statement, 1 true statement. So to finish this off, to actually show the inequality on the graph, because that was the entire point of this question, all we need to do now is shade in the area that contained that true point. So if we go back up to our graph, the point that worked for us was 0, 2. So this was the false point, and this was the true point. And so we want to shade this entire part of the graph that contains that true point, because this whole region is what fits our inequality. Don't be lazy and just do a quick little shade like this, right? That's not really what we want. You don't have to completely fill the entire area, but at least try to show that you're including the entire area in your solution. One other thing to keep in mind, we can kind of reason our way through this if we just look at the y values. So remember, this point right here was y equals 2x plus 1. And so if we want y to be greater than 2x plus 1, that means we want the y values to get bigger. And y values get bigger when you go up. So it kind of makes sense that we would want the area above the line rather than below the line. Don't rely on that. It's an easy way to get a sense of where you're going, but I do want you to be testing points just to be sure, because sometimes the equations are set up in a way that can kind of trick you. So let's give this a shot with another one. So we're going to graph y is less than or equal to negative 2 over 3 x minus 1. Okay, so now we can get going on our inequality. Remember, the first thing we want to do is draw the line. So y equals negative 2/3 x minus 1. That line has a y-intercept at negative 1. So we're going to plot ourselves down a y-intercept right there. And a slope of negative 2 over 3. So remember, if your slope is negative, that means you're going to be going down and right, like this. So our next point, we're going to go down 2 and right 3, which is going to get me a point there. We're going to do it again, which is going to stick slightly off the edge of the graph, but that's okay, right there. Or we can go the opposite and go up and left for points there and there. So let's draw ourselves our line. So there we have it. There is y equals negative 2/3 x minus 1. But I didn't want y equals negative 2/3 x minus 1. I wanted y to be less than negative 2/3 x minus 1. And so again, if you reason your way through it, it would make sense probably for it to be this region down here, because we want to be less than the line, which means we want to be under it. But we are going to test to make sure and to prove that our thoughts are correct. So remember, we want to pick 1 point above and 1 point below. 0, 0 is often a really great choice of a point, just because zeros make things really nice. And then some other point that's in line with that, maybe we'll go with like 0, negative 3. So we're going to go to our inequality. We're going to plug both of those in. So y is less than or equal to negative 2/3 x minus 1. So I'm going to start with 0, 0. So if we plug 0 in for x and for y, we're going to get something that looks like this. And this is where having 0 as an x value is really great, because we don't even have to deal with that fraction. 2/3 times 0 is just going to go away, and we're going to be left with just 0 is less than or equal to 0 minus 1, which gets us 0 is less than or equal to negative 1, which, well, that's not true. 0 is not less than negative 1. So we're going to reject that point and hope that the other one works. Don't just test 1 point and assume. You have to test both. 1 point above, 1 point below. All right, we test a second point at 0. Let's go with -3 instead of -4. That's what I picked before. All right, so we're going to plug in our y value of -3. It's less than or equal to -2/3 times 0 minus 1. And so again, we already know that entire right side of the inequality is going to work out to just -1 because we already did it. And so we end up with -3 is less than or equal to -1. And that one's true. So that's great. So since this point worked, 0, -3, we are going to shade in this entire bottom region, which is what we kind of expected going into this. And so there we go. That is our solution to our inequality. So I'm going to give you one more of these to try on your own, and then we're going to wrap up this video. So go ahead and try to graph y is less than or equal to x over 2. Before you do this, I am going to give you just one bit of advice. X over 2, that's a kind of an annoying way to write an inequality or an equation. So instead of writing it as x over 2, it might be easier to think of it as 1 over 2x, which will make your slope a little bit clearer. So go ahead, get yourself some axes, and then try to draw this out. Okay, so what you should have started with was drawing your line. Our y-intercept in this case is 0, so our intercept is going to be right here at the origin. And then from there, our slope is 1 over 2, so we're going to go up 1, right 2, and get points there, there, or here, and here. And so your line should have looked something like this. Then we're going to test a point above and below. We can't use 0, 0 in this case because it's on our line, so you can never use a point that's on your line because you're trying to test the points above and below the line. So we're probably going to go with something like 0, 1, and 0, -1. So, oops, not 0, 0. So if we plug 0, 1 into this, we're going to get 1 is less than or equal to 0 over 2. Well, 0 over 2 is just 0, so this is 1 is less than or equal to 0, which we know it's not. So that's out. And then we're going to try 0, -1, which is going to get us the exact same thing, but it'll be -1 is less than or equal to 0. And -1 is less than or equal to 0, so that's good. So we want to shade the region that has that 0, -1 in it, which is the bottom part. So our solution would probably look something like this. And so there you have it. This is the first bit of how to graph linear inequalities in two variables. In the second video, we're going to go a little more in depth and look at a specific kind of situation that we didn't cover here. And then we'll see how to look at a graph and figure out what the inequality that gave you that graph was. So once you're ready for that, go check that video out as well.